Hello, Professor. This is Dylan Kelly, and today I'm going to be reviewing Experiment 11, which is oxidation reduction titration. The goal of this experiment is to investigate oxidation reduction reactions. Similar to the other experiment, this deals with titration, however, it includes oxidation and reduction. So what exactly is oxidation and reduction? Pretty straightforwardly put, it is an equation that includes a reducing agent and an oxidizing agent. And so we're going to use a practice formula equation right here, which is permanganate plus iron, and it's real simple to figure out which one's which. So as we can see here, we have the permanganate and iron, and permanganate has a oxidation number for manganate of, let's see, so we have x minus 8 equals -1. So we just move over 8. -1, my bad, yeah. So we move over 8 and we would get x equals 7. So the oxidizing number for manganate on this side is 7. As we can see on the reaction side, it is +2. So that means manganate was oxidized since it lost 5 electrons. However, for the iron, we can see that the oxidation number went from 2 to 3, which means it gained an electron. What this means is that iron is the oxidation agent, while permanganate is the reducing agent. Moving on to the experiment, just like the last one, the first thing you have to do is set up your burette. There we go, burette, by putting it on the burette clamps and then rinsing it out with your titrant, which in this case would be permanganate. Once you clear it all out from air bubbles, gunk, anything like that, you then have to prepare your analyte. Our analyte in this experiment is iron nitrate. So you would obtain 80 milliliters and disperse it into 3 separate 250 milliliter Erlenmeyer flasks. So once you have that done, you will see that iron nitrate has a slight green color, and that is when you start adding in the titrant. The reason there is no indicator in this experiment is because transition metals usually have a different color per oxidation level, which we will see later on. After you fill in the titrant into the burette, in this case all the way up to the top, and that would be 0 since this burette starts at the top, you would then dump it in, well, not dump it, but slowly let it in until you start seeing a reaction happen, which should happen pretty quickly. And you will know it because, like I said about transition metals having their own colors, the green will start to turn into a Dawn Ultra type color, which is a red-yellow sort once iron oxidizes and turns into iron 3. So yeah, once you do that, you can then get your milliliters of titrant. So let's say we stopped at 5. So we would have 5 milliliters of titrant. So after that, you can then find the concentration of our iron nitrate. So first you'd have to take the 5 milliliters and divide that by 1,000, because that is how you convert it to liters. You would then take it over here and you would get 0.005. Take that over, our concentration of the permanganate was 0.01 moles. And then for liters, we use 25 since we had 5 left over just in case. And we have to divide that by 1,000 as well. That would be 0.025. Then you plug it all in. So in total, we have a 0.002 molarity of iron nitrate. That doesn't seem correct, but then again, in the experiment, it was just an estimate that it would be 0.01 to 0.1 for the molarity. Or, somewhere along the lines, we could have messed up in our calculations of solution, in our cleaning, in how much iron nitrate we had, the concentration of that, the concentration of the permanganate. There's tons of different ways that a result like this could have happened. It's not out of the ordinary. It just means along the lines we messed up, or that what was I saying? or that the permanganate could have been messed up as well. But yeah. Oh, I meant to say that this was just a rough estimate and that 0.002 could be a realistic result rather than the 0.01 to the 0.1. But yeah, that is how you figure out experiment 11 and plug in the formula and an explanation of oxidation reduction. Thank you.